All right, so let's do some of these examples together. The first one we see here is y to the fourth times y to the fifth times y to the sixth. Okay, so the first thing we notice is that all of these have a base of y. All of them have the same base, and the operation in between each of these things is multiplication. Okay, so if we got the same base and it's multiplication, our life becomes pretty easy. All we have to do is keep the base and then add the exponents. My exponents are going to be 4 plus 5 plus 6. Okay, so I'll keep my base. It'll stay y. 4 plus 5 is 9, and then 9 plus 6 should be equal to 15. This is the exact same thing as y to the 15th power. For example B, I see 6 squared times just plain old 6. Okay, so once again we notice we have the same base, but there's no visible exponent next to that second 6. And if there's no visible exponent, what we have to assume is it's just 6 to the first power. This is the same thing as 6 squared times 6 to the first. Okay, the principle is still the same. Keep the base, add the exponents. I'll have 2 plus 1 as my exponent. My answer should be 6 to the third power. Okay, for example C, it looks like I have -3 times -3 to the 7th power. And we'll notice we have parentheses around each of those bases. So remember, this is the exact same thing. That first -3 is the same thing as -3 to the first power times -3 to the 7th power. No different. Even though there's negatives, all I got to do is I got to make sure that my parentheses stay there. It should be -3 inside the parentheses, and then 1 plus 7 is my exponents. And I should have -3 raised to the 8th power. Next one. So, kind of the same thing. I still have a base of 0.5, and then I have 0.5 raised to the -3rd times 0.5 raised to the 8th. Okay, first time we're dealing with negative exponents, but the rules still hold up. Okay, so I should have 0.5 raised to the -3 plus 8 power. -3 plus 8, you could use the calculator if you like, but that should give you the same thing as the 5th power. 0.5 raised to the 5th power is the same thing as example D. Okay, so example E is a little bit tougher because there's multiple things going on here. Okay, this is the first time we're dealing with coefficients. Okay, there's numbers in front of my variables, there's numbers in front of the variables with exponents attached to them. Okay, so here's the principle you need to remember. Combine the numbers with the numbers, combine the letters with their corresponding letters. Okay, so what I see here is I see 2a times 9b to the 4th times 3a squared. Okay, the first thing I'm going to do is I'm going to try to combine my numbers. And the numbers are just 2 times 9 times 3. Let's do what we can to multiply 2 times 9 times 3. Okay, so when we do that, we'll have 2 times 9, which is 18, and then 18 times 3 is equal to 54. Okay, so I've done my part in combining the numbers. Now, let's think about the variables. We have 2 different variables in this case. We have some a's and we have some b's. Let's start by thinking just about the a's. Okay, I have an a to the 1st power right here, and I have an a to the 2nd power right here. If I have a to the 1st times a to the 2nd, I have the same base, and then all I have to do is add the exponents. A to the 1 plus 2 should give me a to the 3rd power. Okay, so I've combined my a's, and then the final letter I see is the letter b, which is b to the 4th power. Change the color here. This nice green. So I got b to the 4th power, but it's all by itself. It doesn't really combine with anything else, so it just stays as is. At the end of this, I'm going to have a b to the 4th power. So all I have to do, this is going to be my final answer. I'll have 54a cubed times b to the 4th power. Okay, next one. I've got j squared times k to the 4th times 12j. Okay, combine the numbers with the numbers, combine the variables with the variables if they match. Okay, so the first thing I see is the numbers. I see a 12 here, and then I don't really see anything else. So these are just imaginary ones. 12 times 1 times 12 is the same thing as 12. So my leading coefficient should be just 12. Okay, next thing I'll think about is the j's. I've got a j squared right here and another j right here. That's the exact same thing as j squared times j to the first power. Add the exponents, it should be j to the third. And the last thing I see here is k to the fourth power, which is right here. K to the fourth is the same thing. It doesn't really combine with anything else, so I keep it separate. This right here should be my final answer. 12j cubed times k to the fourth. Okay, example G could be our last one. I've got negative 4c cubed plus times z, or excuse me, times 7d squared times 2c to the negative second. Okay, first step, see if you can combine the numbers. I've got a negative 4 times 7 times 2. Negative 4 times 7 times 2. Negative 4 times 7 is negative 28. Negative 28 times 2 should give you something like negative 56, I believe. Okay, so I've combined my numbers. Now let's think about the variables. Let's go in alphabetical order. We've got c cubed times c to the negative second. C cubed times c to the negative second. Same base, so we add the exponents. 3 plus negative 2 should give us c to the first power. Don't really need an exponent. It could be c to the first or just plain old c. I'll write c to the first though. And the last thing I see here is d squared. D squared doesn't really combine with anything, so we leave it at the end. Should have negative 56, c to the first, d squared. We can actually do the last one together if we're looking for a challenge, but the principles are pretty much still the same. So first step, let's see if we can combine the numbers. I've got negative 5 and I've got 8. And this is obviously multiplication between if we don't see a symbol. So if I have negative 5 times 8, that should give me negative 40 when I multiply the numbers together. Okay, let's go in alphabetical order. The next letter I see here is a cubed, and then over here I see an a cubed. So I'll have a cubed times a cubed. Same base, add the exponents. 3 plus 3 should be equal to 6. I should have a to the 6th power. Keep going. I've got b to the 5th and b squared. Same base, b to the 5th times b squared. Keep the base, add the exponents. 5 plus 2 should be equal to 7. And then the last piece I see here is, let's go with blue, c all by itself, c to the first power, times c to the 7th, c to the first, times c to the 7th. Keep the base, add the exponents. 1 plus 7 should be equal to 8. And this right here should be your final answer.